Welcome back to this Python tutorial series on constructing a recursive descent parsing algorithm for a calculator. And in today's video, we're going to be finishing up the factor and final productions. So to begin with, in the last episode, we finished and we touched up on T2, T1, term, statement, and start. So now all we have left to do is implement these two last functions. So let's do factor first. And we're going to be able to have a previous value, because if you remember, for the factor, we're going to pass in, we're going to return, we're not going to pass in anything. We're going to actually return values from this function. So a factor is a final, and a final is a number or an LPAR, and a factor is a final or a negate. So we need to check to see if these two values appear. If these three values appear, so number, or negate, or LPAR. I'm just going to copy and paste this from here. If it's else, then we have an error, so we're going to print error expecting number, negation, or left parentheses. Return none. Now the problem with this one if statement is that a factor goes to the final on a number while it stays in factor on a negate. So we're actually going to extract the negate and turn that into its own elif statement. So if it is a negate, what we're going to do is we're going to consume the symbol. So we're going to say my iter.next. It's going to consume. And then we're going to get the token from the final of my iter. And then what we're going to do is we need to somehow negate the value of this token from this. So we're going to say if token is none, some kind of error occurred, we're going to return none. This way we check, that way we're not trying to negate a non-numeric value. So what we're going to do is we're going to say token.value is equal to the string value of the negative of the float value of the token.value, because we store the value of the token as a string, so we have to convert that to a float, then we negate it, and then we have to turn that back into a string. So this is how we can get around this. So now what we can do is just return the token. And then here, well, since we're peeking ahead, we're not going to consume anything, we're simply just going to return final. We're going to return final of our iterator. And now let's define our last function, final. So our final is a number or an LPAR. So we're going to peek ahead. This is a number or an LPAR. And we're going to say if token.token is equal to num. If it's a number, then what we're going to do is we're going to return my iter.next. What this does is it consumes the symbol. So if it's a number, then we're simply just going to return that value. If it's not, we're going to say elif token.token is equal to LPAR. And if it's not equal to either of these things, then we have an error because we don't have an epsilon statement. So we're going to print error expecting number or left parentheses. Return none. And then now we're going to consume this statement right here. And after we consumed it, the next thing we need to do is to get the value from a statement. As we can see here, the final calls the statement value. So we're going to call statement to my iterator. And then what we need to do is we're going to say if value is none, return none. This occurs on an error. And then the last thing we need to do before returning anything is actually checking to see if the right parentheses is present. So we're going to say token is equal to my iter dot next. We're not going to peek ahead. We're going to actually consume the symbol. And we're going to say if token dot token is equal to our par return value, else print error expecting right parenthesis. Then we're going to return none. So there we have it. We have final and factor net implemented. So now let's actually run and do some debug code. So let's do our original example. So now let's debug. We're going to say to the negation of 3 plus 5 times 7, negative 56, which makes sense. 3 plus 5 is 8. 8 times 7 is 56. We're running the negative of that value. So as we can see here, we have a working example. The negation of 1 over 7. Let's take the negation of the negation, and that is an error. So that actually throws some kind of error when we do that. So we cannot negate, but we probably can do the negation of an expression inside a parentheses. So this does work. This way, our grammar will not work if we have a long list of negations, but it will work if we surround these negations and encapsulate them inside of statements, instead of parentheses. So here we have a semantic error. Run that again. There we go. So that is it for today's video. And in the next episode, we're actually going to introduce exponentiation. So stay tuned.